Hello, I hope this video finds you well. We're going to talk about passing by reference, and I think something that's good to do once you've gone through this, if you haven't already, is take a look at the actual coded examples that I use. So I want to talk about some simple definitions to start with, and these are really simplified. When I start working with students in programming, I talk about what are called primitive types, and these variables store the value at the memory location. So here A is a primitive type, because you can see the 9 is stored right inside that location. So if I go to A, I find 9. And then reference types. These variable types store a reference to the data in memory. So B is a reference type, because if I come to B, I don't find the data, I find a reference to where it is. So this would be some memory address that if I got there, I would go there and then find that data. Again, this is an extreme simplification, but it's a good starting point. And what I really want to get you to understand when you're done this is that when you're dealing with data structures as a beginning programmer, like lists or arrays, they are reference types, and this is going to hopefully explain some odd behavior you might have encountered with methods. So let's start with a kind of example here. A student points at a chair. So here's a student and they're pointing at a chair, and then another student says, hey, where's the chair? And they say, it's over here. And then that second student shows up and points at it. So now what you have is a situation where you have one object or one thing, and you have two students referencing the chair. You have two references, but one object. So if one of those students flips the chair, let's say, and then the one student disappears, that other student sees the flipped chair. So you see what I'm trying to get at here is that both the students are pointing at the same chair. So if either student makes a change, the other student is going to see that. So if this student here flips the chair and then ceases to exist, the original student is now seeing that flipped chair even though they've done nothing. Now, let's talk about what this means in terms of programming. So let's start off by talking about passing by value. So I have a really simple Python program here on the side, and this is your volatile memory. So think of this like the memory in your computer, and this is a great opportunity if you're an IB student or any student of computer science, is to really take a moment and distinguish between volatile memory and non-volatile memory. So think of this just as your cache or your RAM. This is where the program's running. So when I run this program, the first line that runs is A equals 9. And this is what happens in memory. We create some space in memory for an integer. We call it A, and we put a 9 in there. So then when the function do this is invoked, some more memory is put aside for that function, and then this value B here, A, is passed into it. But notice what's happening is you're passing by value, so you're actually making a copy of the 9. So then when the next line of the program runs, which is B equals 10, notice that the 9 gets overwritten here. Watch this closely. So initially, A and B are both 9, and then when do this runs the line B equals 10, that value changes. So that when the function ends, and we print A, what's going to be printed out is 9. And so the big idea here is that when you're passing a primitive type into a function, you're passing a copy of the data. You're passing by value. So any changes you make to that parameter have no effect outside of the function. So now let's talk about when you pass by reference. So I have a very, very similar example here, but instead of A being a primitive type, which would be an integer, I've made A a reference type. So in this case, it's a list. So what happens now that's a little bit different is when we run this first line of code here, we generate that memory space for A, but we don't put the value in there. We put a reference to where the value is. So if we access A, we go to this point in memory, and then it redirects us to where that is. So now when we invoke do this, we don't actually pass a copy of the data. What we get is we get this variable B, and we put the reference to where it is. So now think back to that chair example. We now have two references and one object. Both of these are pointing to the same object. So if B makes any changes, those changes are going to remain after the function is done. So when this function runs and we say B at 0 becomes 10, and so that's changed the value here to 10, notice both A and B are pointing at that changed data structure. So then when the function ends and we print A, what we actually get is 10-1. And that's the idea of passing by reference versus passing by type. And this is something that's really important to understand as a beginning programmer. So what does this mean? Well, what it means for us is that when dealing with data structures, be aware that when passed by reference, any changes made in the method will remain after. So if you're ever writing a function and you have a parameter that is a list or an array or any other reference type, be very aware if you change it. Because when that function is done, those changes will persist after the fact. When you're writing just individual functions, not a big deal. But if that function is part of a bigger project, this can have really serious effects. And the second thing is watch for post conditions that say a passed parameter must not be changed. A lot of times you'll see problems, and I've seen this on the AP exam and I've seen this on the IB exam, where you'll be doing something and it will indicate that the passed parameters, or sometimes you'll see something called the implied object, which we haven't talked about here, must remain unchanged. And so for the purposes of what we talked about here is if there's ever a parameter that is a reference type, be very cautious if you change it, because like I said, those changes will persist when that is done. I hope this video helped, and you should take a look now at the examples that I do to illustrate this in Python. Have a great day.